All right, hello again, Algebra 2 people. So in today's video, we're going to continue talking about quadratic linear systems. In the previous video, which I'll link to at the end of this one, we talked about how to solve these kind of systems algebraically, and I'm going to do one more example just as kind of a refresher of that previous video. But at the top of the screen here, you see the three situations. Obviously, we can, if we have a parabola and a line, three things can happen. Either they're going to intersect in two spots, they're going to intersect in exactly one spot for one solution, or they'll never intersect, which would be no real solutions. So, but the point of this video, after we do this last example here, is going to be kind of going backwards and looking at a graph and being able to determine what the system would look like just based on what the graph says. So, but let's go and do one more example from previously. And if you remember how to do this, if you want to pause the video, excuse me, and work this out on your own, I encourage you to do that. Let's go and take a look at the solutions. So notice they're both y equals. So I'm going to set them both equal to each other. And then once we have that, we got to get everything on one side and then factor and solve. So if I move everything to the left-hand side, I have this. And of course, I don't really want a negative x squared, I want a positive x squared. So I can just multiply the whole thing by -1 and change all the signs. And that way it'll make it a little easier to factor. And of course, we know how to factor that. It's just -1 to -4. And we also know that the solutions to this would be +1 and +4. And if you remember what we do with that, once we know the x, of course, we have to also find the y. You can plug those into either of the equations. I like doing things as easy as possible, so I'm going to plug it into the linear equation. So if we plug in the 1, we have y equals -1 plus 1, which of course is 0. So one solution would be 1, 0. And then the other solution would be -4 plus 1, which is -3. So the other solution will be at 4, -3. I'm not going to bother graphing it just for the sake of the time of the video. But the main thing is that you know how to solve these things algebraically. Okay. I'm going to turn over to the next page, and this is going to be, we're going to talk about 3 problems. So example 2, we're not going to solve this algebraically, but I do want you to take just a moment, pause the video, read the problem on number 2, and then you can open up Desmos and see if we can graph that. We'll talk about what those solutions look like in just a second. Okay, so what we have 2 like public swimming pools that track their attendance. So they both open on the same day, and they track their attendance. And you see pool A, that's the one that has that constant kind of increase in attendance each day that it's open. But pool B kind of started off increasing attendance pretty quickly, but then kind of, who knows what happened, but something happened and they started kind of dropping off on attendance. If we want to solve this thing and you put it into Desmos, and I've already graphed it and kind of changed the window, this is what you would see. Now again, I've already changed the window on this, but we can see our 2 solutions here, right? And clearly there's 2 solutions. So again, if you just click on one of the lines, we can click on those 2 points and see what those 2 points are. Now, before I go back to the smartboard screen, let's think about what these things mean. Remember, my x value was the number of days since it was opened, and the y value is the attendance, or the number of people that were at the pool that day. So if I write down those solutions, and they were -4, -108, and 15 and 424. But hold on a minute here, because this is a real life thing. So we have to talk about, which of those solutions is reasonable. And clearly, we are not living in an age of time travel, at least not yet. And so we don't know what it means to be negative days, and we don't know what it means to be negative number of people. So the only actual solution that's reasonable is the 15 and 424. Is the -4, -108 a algebraic solution? Yes, but a lot of times, and this is going to happen over and over again as you continue through different math courses, you might find an algebraic solution, but it's not going to be an actual, like, real life solution. That's what we call reasonableness. Okay? So when these two pools had the same thing, the only time that happened was on day 15. And on that day, both pools had 424 people. Okay, so just kind of keep that in mind too. Again, we can use Desmos to find solutions to these things. You have to know how to do them algebraically. As you're doing an assignment or even a test, something like that, you should always still show your work so we know where the answers come from. But by all means, we can use technology to check our answers to make sure that we got everything correct. Okay. So let's go and move on to the next example here, example 3. And this is kind of what I was talking about a second ago, where we want to be able to take a system and go backwards. So we're given the graph, and we wanted to figure out which of these choices would model the graph shown, right? So what I would do is, and especially on a multiple choice, look at the quadratic first. We see that the quadratic is upside down. So that means we know what the A value would have to be, at least in a general sense. So we can eliminate two choices right off the bat. Since we know it's going upside down, we can eliminate A and D because the x squared term there is positive. So we've got it narrowed down to either B or C. Now we look at the linear equation because the two quadratics are the same thing on two choices. We look at the linear equation and we see that it has a positive slope. Well, they both have a slope of 2, so that's fine. But the y-intercept is clearly positive, so that means it has to be choice C, because if it was 2x minus 30, it would be down here somewhere. Okay? Now, if there's multiple choice, you can just kind of do the process of elimination to kind of figure out which one is the correct answer. But what if it's not multiple choice? So let's take a look at this last one here. So if it's not multiple choice and you're given a graph, we need to be able to go through the process of actually finding the equation. Okay? But before we do that, let's go and write down what we know. What we see where the vertex is. Our vertex is right here, and that's the point -3, 1, 2, 3, 4, -4. And we also see our two intersection points here and up here, and we see those 2 points are -2, -4. Sorry, -2, -3. Sorry about that. -2, -3, and the other one is -6, 1, 2, 3, 4, and 5. Okay, now if you remember back a little while ago when we first started talking about quadratics and the different formats of them, we can write this equation in vertex form almost. So if you remember, I'm going to do this kind of up here where I have some more room. So vertex form would look like y equals a parentheses x minus h. And remember, this is my h and k. So x plus 3 quantity squared minus 4. But the problem is, I don't know what a is. So to do that, I can plug in either one of the two intersection points because they're both on the parabola, so I can plug either one of those in for x and y to find out what a is. So let's go ahead and do that. So I'll plug in -3. So I have that, and then obviously the inside of the parentheses, -2 plus 3 is just 1. 1 squared is also 1. So I can just go ahead and add 4 to both sides, and I see that a is equal to 1. So that means my final answer here for the vertex form would be y equals, at 1, you want to put that in front of there, you don't really have to, x plus 3 squared minus 4. And that's totally valid if it's a short answer type of question. If you but a lot of times it might be asking you for standard form. So we can take that standard form and then just multiply it out. And again, I'm going to do that over here. So I'll say y equals x plus 3 squared minus 4. And remember, that's a FOIL or box method on the x plus 3 times x plus 3. So that becomes x squared plus 6x plus 9 minus 4. And then we can combine these guys for my final standard form of y equals x squared plus 6x plus 5. And then finally, for the equation of the line, we've been doing this in Algebra 1. We see our y-intercept is here at -7. And we also see our slope is going down 2 and over 1, down 2 over 1. So that means my b is -7 and my slope, my m, is -2. So I can just write the equation of the line as y equals -2x minus 7. Okay, so if you're given a graph and wanting to write a system, a quadratic linear system, write down the vertex, write down your intersection points. You can use that to write out vertex form and then convert it to standard form. And then for the equation of the line, find your y-intercept, find your slope. You can also use the two intersection points to kind of do it the long way using point slope form. Either way would be okay with that. As always, if you have some questions, send an email or talk to your teacher. And until next time, stay safe.